Hey everyone! In this video I'm going to talk about survey sampling, which is one of the main data collection methods in quantitative social science research. So a lot of the papers that you're going to read in American politics and beyond use survey data to study public opinion and behavior. Um, and maybe one direct example that shows us how relevant surveys are of course, the upcoming US presidential election. If we are interested, or if you guys are interested in looking at latest polls and or thinking about potential, possible, likely outcomes of the election, there's one quick website that I wanted to show you in case you're not aware of it already. Real Clear Politics, which provides a great overview of latest poll results across states and as well as nationwide. And of course, here we can see latest polls that were published. I'm recording this video on Tuesday, October 6th. So we see latest polls for key states like Florida, Michigan, and so on. And we see the results for these individual polls, right? So obviously it's interesting and important to kind of get an idea of public opinion across different states, and ultimately this will help us provide predictions to kind of see what likely outcomes might be in the actual election, right? So there are a lot of people who try to aggregate these different poll results from different surveys in order to provide some probabilistic statement about how likely it is that one candidate wins over another. And one really great set of predictions and overview that is available online that I encourage you to check out was published by The Economist. Um, oh, okay. Of course, we have to. Let's see. We manage some cookies first. But then we have this website that shows that basically the idea here is to aggregate all these individual state level polls and provide kind of a probabilistic model for actual results in the electoral college, and then provide some probabilistic statement as to which candidate is more likely to win the election. And as we can see here, right now our model predicts Joe Biden is very likely to beat Donald Trump in the electoral college. But of course, the prediction itself goes beyond this one individual statement. There's a lot of information here about how they're aggregating their polls, how they're kind of quantifying the uncertainty around these predictions, what the underlying assumptions are, and things like that, right? So if you're in any way interested in kind of election forecasting and, of course, also have stakes in the outcome of the election, give this website a look. They also have a great overview of their underlying methodology. Their code is actually open source and it's written in R. It goes a little bit beyond what we cover here in this class. But if you want to take a look or chat more about it in our Q&A session, we can definitely do that and take a closer look at that as well. I think this is a really great resource, so feel free to check it out. But this is, of course, just one example of why polls are important and why polls are, relevant for political scientists in the context of election research. But overall, in general, let me go full screen here again. This, of course, is not only about U.S. Presidential elections, but in general, we are often interested in kind of attitudes and behaviors across a broader population. So in the case of the presidential election, the goal is to make an inference about what 200 million voters or eligible voters are thinking and who are they going to vote for, right? And so obviously we're not able to ask each and every individual voter about their party preferences. Ultimately, due to constraints and resources and things like that, we can only ask a small subset of people, and ultimately rely on several hundred or maybe a few thousand people in order to kind of make inferences about what the broader population is thinking, right? And the important point here is with modern surveys and survey sampling, we can learn a lot about a population as large as 200 million eligible voters in the United States by just asking a few hundred or a few thousand people, right? But of course, this is not a straightforward process. There are a lot of underlying techniques related to how we select those people and how ultimately we analyze these data that allows us to kind of make this inference from the sample, the significantly smaller sample that we have, to the broader population. And that's what we're going to talk about in this video, right? Ultimately, what we'll think about is to what extent the sample that we collect and the respondents that we have in our sample is representative of this broader population, right? So we want samples that are to some extent representative of the population, right? And ultimately, what this means, what does representative mean in this context? Ultimately, what it means is that the sample provides kind of an unbiased estimate of the population. In this case, for example, presidential support, right? So if we were to repeat our sampling procedure again and again and again, the average across all of those samples would be, if it's unbiased, would be equal to the value in the population, right? Of course, the problem is that doesn't always work, right? Here's one very prominent historical example, but in theory, I wouldn't have had to go, all that far back. We could have looked at the last election and the poll predictions based on those too. But this is a very prominent example in the literature, which is the 1948 election between Harry Truman and Thomas Dewey, who was a New York governor at the time. And this election, of course, was right after World War II. The Cold War was starting, and everyone thought that Truman was going to lose. Truman was the incumbent. He was the vice president of FDR, who died in office. And a lot of polls, we have here some polling results, Gallup, Roper, and so on, they all predicted that Truman would lose. And it actually went so far that the Chicago Daily Tribune came out with a story on election, well, the morning after the election night, because they were so confident that Truman would lose, that they published a story, Dewey defeats Truman in the election. And of course, it turned out the actual outcome was a landslide for Truman, right? So this was a polling disaster. Ultimately, all the polls got it wrong systematically. And the question is ultimately, what went wrong? Why were the polls so wrong about the election result in 1948 or 2016? For the answers for 2016 and for 1948 are of course very different because the polls were very different. But at least for 1948, one big part of the answer to the question what went wrong is the underlying technique that went into sampling. So how they ultimately selected the sample in their survey. Those surveys back in 1948, the way they selected their sample was based on quota sampling, right? And so the idea behind a quota sampling is that you have a fixed quota for certain respondents for each interviewer, and these quotas are ultimately the goal of these quotas is to ensure that the sample resembles the population with respect to these characteristics that are included in the quotas, right? So, for example, these could be age or sex, race, marital status, and things like that. And so the idea for each interviewer is to get respondents that kind of match these quotas or match the proportions of these given quotas, right? So, for example, sex, age, race, and so on. Okay. The underlying problem with these surveys was that they were face to face, and the interviewers within those quotas were free to choose within as long as they kind of fulfill the quota requirements, they were free to choose whomever they wanted to interview, right? And so the problem here was this introduced an unobserved confounding, which ultimately led to sample selection bias, which ultimately led to this problem. What is the underlying problem that led to this selection bias? The problem is that the interviewers tended to contact those who were easier to reach, right? The interviewers wanted to, fulfill their quotas and, collect all their interviews and be done ultimately. And it turned out that in 1948, given the socio-demographic distributions, Republicans tended to be wealthier than Democrats, and they were more likely, and the interviewers were easier, or the Republican interviewees were easier to reach for the interviewers, and so that's why we had a kind of a systematic bias towards Dewey as opposed to Truman. Okay. Surveys nowadays, well, surveys after this focus on quota sampling over the years changed, and we changed how we kind of try to select our sample. And one important aspect to kind of get around this problem of potential unobserved confounding factors that might impact sample selection is randomization, and the idea of selecting a set of respondents based on some kind of random process ultimately. The idea behind this kind of random sampling or probability sampling is that every unit in the population, so everyone who is kind of part of the voting age or eligible population, has a known and non-zero probability of being selected in the sample, right? And kind of one subcategory of probability sampling is simple random sampling, where every unit has an equal selection probability, right? So the idea would be we have a list of all 200 million potential voters in the United States, and we can just randomly select 1,000 of them, each of them having the same underlying probability to be selected, right? This process, the simple random sampling, ensures representativeness and avoids sample selection bias as compared to non-probability sampling like quota sampling, because the quota sampling ultimately there's a different non-probabilistic process going on that kind of determines whether some people are included in the sample and others are not, right? We can't really say that every unit in the population has a known non-zero probability of being selected, okay? But if we do have simple random sampling, then we're randomly choosing units from this population, and that allows us to then, or at least makes it easier to make inferences from the sample to the broader population, right? Of course, there are lots of caveats. In practice, we don't have a list of 200 million potential voters or eligible voters. So simple random sampling is not that easy, and there's still sources of bias, for example, due to non-response and things like that. And especially in the recent years, telephone surveys had to struggle with increasing or decreasing response rates. More and more people don't want to answer surveys on telephones, right? So the kind of traditional random digit dialing, random probability sampling via phone surveys is becoming less and less feasible, more and more costly, and also more and more problematic given non-responses. So now there's a move, back to opt-in internet panels, which is essentially again non-probability sampling, but also our techniques of how we deal with these non-probability samples has improved. Okay. But no, just talking about let's see. Let me move myself a little bit out of the way. The important part is, at least for random sampling or simple random sampling, is this kind of stepwise process from our target population. Right, so we have a target population. That's the population that we want to make inferences about. That's kind of the population that we try to characterize. The quantity of interest here could be, for example, support for a presidential candidate, but it could be other types of attitudes or behaviors, right? From that target population, ultimately we're selecting a frame population. That frame population could be, for example, a list of voter files that we can then sample from, right? That's kind of the process of going from the population to an actual, list or something that we can ultimately sample from, right? So like a voter file or, a phone book list or something like that, right? And of course there can be deviations, and that's where potential bias comes in. This is where kind of potential frame bias comes in. If the sampling frame is systematically different from the target population, that's already a source of potential bias. Then we have our frame, our sampling frame, and then we take a random subset of that sampling frame, and that ultimately constitutes our sample. And of course, there can be also sampling bias, so we might, not be able to select units or observations from the sampling frame with the right probabilities or the same probability for all units. But there are even more problems, right? So even after we have our sample, some observations, some respondents might not be willing to participate in our survey, so that creates unit non-response, which again can lead to potential bias. But then we have our respondents, and even if we have our respondents, they might, not be willing to answer certain questions. For example, if these questions are sensitive, or if there's social desirability and things like that. If those are sensitive questions, they might not respond to individual questions, so that's an additional source of bias. And then we have our completed items, the items that were actually filled out, and still there can be bias, namely response bias, if there's something like social desirability, if they're lying about the answer, if they're embarrassed about certain aspects and things like that. So as you can see, the idea of kind of simple random sampling to make unbiased inferences about the population, the idea itself is quite straightforward. But once you get into the details, there are a lot of steps where this can ultimately go wrong, right? And we'll talk about some of these in more detail as we go along. All right, I'm back in my corner. So as I mentioned, in practice, it's often a lot more difficult to obtain a representative sample. And there are different issues and different challenges with different types of surveys, right? So for example, there are problems with telephone surveys where again in the context of election polling, our inferential population are all eligible voters, right? And like traditional telephone surveys often are based on what is called random digit dialing from phone books. So ultimately they take area codes and then take like the first couple of digits of the phone number and then randomly change the last 3 or 4 digits, and then that through that process kind of randomly sample respondents. But this process is becoming more and more difficult due to cell phones. Some people have multiple phone lines, more phone lines than others, and so they, technically have a higher chance of being included in the survey. And with cell phones, people often, if you get a phone call from an unknown number, you just push, you just don't answer the phone. You just, click it away, and so that leads also to unit non-response, right? So telephone surveys, for example, have a lot of challenges, especially in recent years. An alternative, and that's something that I already kind of alluded to a little bit, are internet surveys, right? So, for example, opt-in panels, online surveys, which are ultimately non-probability samples. So people can opt in, they get some incentives to kind of fill out a survey every now and then. And so these have advantages and disadvantages as compared to these traditional telephone surveys. For example, they are cheaper, but ultimately they're not probability samples, so they're not directly representative. And of course, when it comes to internet use, there's also a kind of a divide with regard to, rich versus poor and young versus old. People might be less internet savvy or less likely to be online, less likely to, if they're older, less likely to sign up for these surveys, right? But there are more and more statistical techniques to correct for potential sampling bias through statistical methods, and we're going to talk about those going forward as well. So to provide a quick overview, a quick summary of sampling, one key important idea in kind of survey sampling is the idea of probability sampling, where we have a known and non-zero probability for each observation, for each respondent to be included in the sample in order to ensure representativeness, which ultimately, this kind of framework is really important because it helps us quantify and calculate the uncertainty around our estimates. So how certain we can be about our sample and to what extent our sample is an accurate assessment of the actual population, right? So we need kind of a framework of the underlying sampling procedure in order to accurately compute this uncertainty. But there are lots of sources of bias. I went through them relatively quickly, but they're also described in the chapter, from unit non-response, individual respondents not volunteering to participate in the survey, item non-response, people just don't want to answer a certain question. We have social desirability bias with regard to specific responses, or we have something that is called differential item functioning, which basically describes that, so for example, if you're trying to measure political knowledge or some concept like that, certain questions to measure political knowledge might be harder for some people and easier for other people. And so these differences in how difficult a certain item is also can kind of bias our result, right? There are, but so these are a lot of challenges and a lot of problems, but there are also a lot of techniques to kind of overcome them and to address them. So specifically, when it comes to survey methods for sensitive questions, there are, for example, list experiments and randomized response methods that allow us to measure even attitudes that are sensitive, where people might not be willing to volunteer an answer. There are methods to kind of allow that, and we're going to go through an example later on with list experiments specifically, where people are given basically a number of options, and I'm going to talk about this more in detail, and then they're not saying which of these potentially sensitive items they actually, for example, agree with or things like that, but rather say, okay, I agree with, 3 of those, but I'm not going to tell you which. We're going to talk about it in one of the next videos in more detail. The randomized response technique is a little bit different. You're kind of introducing a random component. Say, for example, I'm asking you about kind of a sensitive question. I don't know, for example, like people's, I don't know, sexual preferences, where they might be where they might not be willing, where there might, where there might be sensitive questions, and respondents then kind of roll a die, for example, and have the instruction to kind of give a specific response, like a non-honest response if they roll a 1 or a 6 or something like that, and then if it's a 2, between a 2 and a 5, then they're supposed to give kind of the honest response. And so there's this introduced uncertainty that gives kind of plausible deniability for respondents in their response behavior. So this is a kind of a very quick explanation. We're going to talk more about list experiments and actually look at an example. All right, so we're already at about 24 minutes, so I'm going to take a quick break here, but in the next short video, we're going to look at one example of a survey of civilian attitudes and war against insurgency in Afghanistan, and we're going to jump into some R coding as well.